Okay, well, welcome. This is talking about flat Earth. Let's go through this lesson, and then hopefully we can knock out some homework together. That'd be amazing. So comparing data sets using measures of spread. This is day 2. I probably should have wrote 0.8 day 2, aka pot 2. So this is of course from the beginning of your book. 0.8, it's like the whatever it is stats. So we can use measures of spread. So seeing how far apart our data are. Like, are they all close together? Are they far out? So more or less, if you take all the freshmen and find their heights, okay, especially for the boys. You ever see those 9th grade boys? They're very, very small. It's like their backpack is as large as them, right? Running through the halls. I see this every year. And so, their height, most of the freshman boys are about the same height. But if you take all the boys, right, all these young men from 9th to 12th, you have much more spread of your data because you have some people like Yarden Lashem, who's really tall, and then you have some people who are very, very short. I'm not going to call them out. So looking at the spread. So range is the difference between your biggest and your smallest. Standard deviation is how far away you are from the mean. So the bigger the standard deviation, the more spread out you are. Okay, and we can use these to compare sets of data. So I do this when I compare 2 sections of my class and they take a test. I'm like, okay, what are the averages? What are the standard deviations? So maybe one of my classes had a higher average, but a bigger standard deviation. Is that necessarily better? So it's one of the characteristics we can use to compare different sets of data. So how do you find central tendency and measures of spread? Same process as we used in the previous section, but we look at other data. Okay, this is just a review of how we did it before. Example 7. Metabolic rate is the rate at which the body consumes energy, measured in calories per 24 hours. During a study on diet and exercise, the metabolic rate for 2 different groups of men were observed. Which group has a greater variation in metabolic rate? So we're not asking which is the highest average, which one has more variation. So we're looking for which one has more spread. So the way we can do this, we're going to put all of group 1, and I'm going to put this in list 1, and I'll put this in list 2. So we're going to use 2 columns, and we're going to do it in our calculator. We have our calculators out, charged, ready to go. So if you don't have one, you need to bring it to class. All right, it needs to be charged. There's a charger in the IT room now. So you have to have your name. This is new yesterday. Name on the calculator, and probably keep your cover unless you put your name on the cover as well. And there's a charger right over here behind me. Does anyone not have a calculator today? Because I have some student ones that I just want you to use. Have yours in the future. I don't know if these will work because they're on press to test mode. So put this one in the first column, the second one in the second column. Go ahead, try that out. So go to add list and spreadsheet, and I'll put this in the first column. Okay, so I entered in all the numbers. I went to the very, very top. You can see I named my list. One is called group 1, the other is called group 2. So you have to make sure that you don't just go to where it's the equal. You have to you have to go up to where it says A and B. And that's important for when you make the graphs of histograms and stuff. Okay. So, do you need more time to enter this in? I'll give you another minute or so. Wait, what would you put in for titles? You're at the very, very top? Or you don't need equal one? Because you can have a space. You can have a space. If we're supposed to do, it has to be no spaces. Yeah. Cool. Okay. So, now that we're here, notice I'm just on C, right? The column C, I'm not on any. What? So I can go menu, statistics. Hold on. Come on. Why is it doing this? It's telling you what? C. Menu, statistics, stat calculations, one variable, stats. Okay, so I want one list, okay. And then I want the first list to be an A, and I want my result column to be C. Otherwise, if I put it in B, that's going to overwrite everything I have. Okay. Yeah, one list. So notice that everything right here in my C and my D columns, this is from my group 1. Then I'm going to go, and I'm going to do the same thing, but in group 2. Which column should I put the results in? E, exactly. I don't want to overwrite anything I've already done. So I'll just go through again. Menu, sets, stat calculations, one variable, stats. And I want one list, but this time I want it to be B. And I want to put it in E. Oops, come on. Just have to retype E. Cool. So, okay. Ooh, this is crazy. Okay, let's go and look what's happening. So remember, this is the, I'm going to name this like the group 1 stat. It's kind of long, whatever. Just so I know which one it is. I can call it G2 stat actually, and G1 stat. Because we're not actually going to use these titles. It's just to help us when we're looking at it. Okay, so I know this first 2 columns are my first stats. Okay, let's come back over here. Let's see what we're supposed to be doing. Okay. So which group has a greater variation? There's a couple different ways we could measure this variation, right? I could look at the mean, I could look at the median, I could look at the range, and I could look at the standard deviation. There's like 4 different things I could look at. Okay, so let's do group 1 first, right? That was my first column, and that's why I called G1 stats. That's the information I'm going to pull from it. Okay, let's go right here. So the mean. Come here. Oh, nope. I was pushing the wrong one. Okay. Push here. So I see the mean is 1603.9. Mean, that's your X bar, 1603.9. Okay. And then what will the median be? What will the median be? I wasn't sure if it told us. Boo. Okay.
The median is 1591.5.
Awesome. So, oh, sorry, you said the median?
Yeah.
1591.5, yeah. So X tilde, 1591.5. How did you find that?
That's on the top of it.
Do I just not see it?
You just scroll down.
Oops, cancel. Oh, duh. It's one of the 5 numbers. It's right here. Okay, cool. What's my range? Do we know what our range is? Exactly. Look at the min and max. So we said our min is 1429. And our max is going to be 1764. So if you subtract those, you get 335. And then the standard deviation, you look at SX because this is just a sample. It's not the metabolic rates of all men. This is only a sample of men. Okay. So SX is 100.2. Okay. So if we scroll over, we can do the exact same thing for our second group. So you see our mean is roughly the same, 16.04.
Yeah, I got a different one.
For the second one?
Yeah,
Uh-oh. What did you get for the second one?
I got 1619. I got 16.
Should be 1604 when I did it before. Yeah, for the second one? 1604. You might have like transcribed a number or two. It's 20 numbers and it's very easy to like mess up. Yeah, it should be 1604. And then the median is 1605.
Oh, we're doing the night golf out from the
Okay. Yeah. So the mean 1604, median 1605. So right away, we're trying to see which one has greater variation. Just looking at these two numbers, these are very close. All right, the median and the mean here, they are very close. Okay, I'm just gonna blow this up again. Come on, full screen. Okay, these two are very close. Let's see if we're right. Let's take the range for the second one. Just take the max minus the min. So 1723 minus 247. Your calculator literally will tell you your min and max. This is 247. Okay, so the right side, not only is the mean and median closer, it has a smaller range. Okay, so it seems like, ooh, everything is more tight with the second one. And so if you look at SX, it'll be 54.6. So this is smaller, right? All our values are closer on average to the mean, yeah? That's awkward. 1476. Because I was thinking the answers too. Thank you. Ooh. Okay, so judging on these two, which one has a greater variation? Yep. Group 1, greater variation. Right, because it's a higher standard deviation, it's more spread out. The mean and median are a little bit farther apart. It's not as strong as an argument, but the big two are the fact that the range is bigger and the standard deviation is bigger. Yes? Yeah, but like by seeing that the mean and median were close for the second one, we're like, okay, we already have an idea forming. It's good to look at all of it, and not, yeah, because you always want to take everything into account and be meticulous. So when I was studying aerospace engineering, there was this story my professor told me about. It's not the like known knowns, right? You know things about things you know. And then there's the known unknowns, like you don't know about these things. I know, it's getting really crazy. The thing that screws people over and causes big loss are your unknown unknowns, things you don't know that you don't know. So for instance, Boeing recently did not know that the whole thing about the 737. They didn't know that their software did not have this redundancy that caused these planes to crash. And so the 737, the thing that's like trying to bankrupt Boeing right now, that crashed twice last year and killed hundreds of people. Yeah, because so my friend works for Boeing, and there's like redundancies upon redundancies in anything with satellites. So the fact that this one thing, the very small little chip, that's all that caused the crash, that's crazy. Like they didn't have these fallbacks in place. And with planes, you don't want it to be a 99% success rate. You don't want 1 out of every 100 planes to drop out of the sky. You want like no planes. So the way they design the planes, they're like, okay, this is what we need to do. So we design it with like, if it has to hold 100,000 pounds, let's design so it can easily hold 300. That way it's like these margins of error, like even if we accidentally screw something up, we should still be within the bounds that we need. Anyway, Pratt and Whitney, we're studying thermodynamics, back to the story of me studying aerospace engineering. So we're studying thermodynamics and like how different materials have different properties of heat capacity and stuff. So when you're having a blade and a turbine and a jet engine, like literally there's such high heat and pressure because explosions, right? Like with gas, jet fuel gets really, really hot. Okay. So ceramic, like the things that you make mugs out of, like coffee mugs, they hold heat very, very well, and it's great. So they can hold heat very well. You know, they can make the turbine blades. It'll be lighter. This is genius. This is amazing. So they spent millions and millions of dollars designing these turbine blades out of ceramic because it'll be great for heat. And do you know how they test jet engines? Like, because imagine you're flying way up in the sky. What can hit your engine? Birds. So the way these people test these engines is there's a test facility where they hook up the jet engine and then they like have it going full power, and then they have these frozen birds, dead birds, and they throw them in. Yeah, better than live birds. They use dead birds. Okay. Anyway, whatever. The thing is, they had thought so much about, oh my gosh, like this ceramic, it has very good compression properties. It can withstand, high force, as long as it's a gradual force. It has really, really good heat properties. But they didn't know that they didn't know about the issue of the ceramic shattering. So when they threw a dead bird in, it shattered and sent these ceramic pieces everywhere. And that's really dangerous. You don't want to sit in a plane where, a bird goes and hits your engine, and then you get smucked by a ceramic shard going hundreds of miles per hour. So that was millions and millions and millions of dollars that they lost because they're like, we got to scrap the whole thing. So I thought that was an interesting story because you got to take everything into account, especially when you're in a place where there's not a lot of room for failure. So airplanes, a lot of aerospace. So that's what I did for a year. That's what I studied for a year. You have to take everything into account. So that's like a story that's burned in my mind. So I'm like, okay, I know these are the things I don't know, but I'm always like, what's going to come out of nowhere and hit me? Because whenever I'm driving on the 405, it's not me. I'm not going to be the reason I get in a car accident. It's going to be these hooligans who drive 120 miles an hour and not paying attention and smack into the back of me. So I'm always on the lookout and trying to keep everything into account. And then once I take into account, I'm like, okay, now what can I pull out and ignore? But I always want to look at everything first. That's why I kept the mean and median. All right, that was a little bit of a tangent, but whatever. I thought it was interesting.
Yeah, is it the movie Soul?
Yes. Yeah. I remember when that was happening, the landing in the Hudson. It was 2008, 2009, right? Something around there. I was still a wee child. Frequency distribution or frequency table. It shows how a data set is partitioned among several categories or classes by listing all the categories along with the number of data values in each of the categories. So let's do something fun for a moment. Since this is still on your calculator, we can go to this red thing right here. Do you see the red? Ooh. Okay. These are my G1 stats. So I can click this.
How do you get to the red thing?
Okay. So you go to your home page. Ooh. Go to your home. And then this is add data and statistics. This is bottom. Click it. And this is what should pop up. Is the caption? It doesn't matter what the caption is. So if you click on the bottom, it says click to add variable. You can pick which one you want to put in. And I'm going to pick group 1. It's my first things. So this is called a dot particle. You can kind of see where we're clustered around, right? There's a bunch of people, almost 3 on top of each other. And I decided to show it to you right now. So if you click menu, plot type, I can make a histogram. Right now is a frequency chart, more or less a histogram. So you can see the frequency on the left side. You see, there's literally one of them. Then there's 3 in this group. We have a little bit of cluster right here.
Wait, how do you get a frequency?
So menu, plot type, histogram.
How do you use this?
What?
How do you use this? Where you input the numbers?
So if you go to the home and then go down to add data statistics, I can make this into a box plot. This is what we're going to be learning tomorrow. But let's see, I can actually add a second variable. Let's see. Nope, X out, come on. You can switch between groups. See how they're different. Ooh. Okay. Anyway, let's go back and I'll finish the lesson. I just thought I'd show you this. Okay, so check these out. These are the winning scores for the first 42 Super Bowls. To make a distribution table, what do? You determine the range of the data from 14 to 55. All right, their lowest was 14. The highest was 55. Lowest 14. Where's my high? 55. Determine the class, the categories of equal length. So more or less, I want to have equal spacing. It's kind of like when you make a graph, right? You want to go equal tick marks. So I see my ranges from 15 to 55, so I can go by tens, like 0 to 10, or let's see, 0 to 9, 10 to 19, 20 to 29. That way there's like 10 numbers, right? Because if you go 0 to 9, there's zeros, 1, 2, 3, 4, 5, 6. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's like 10 numbers you can put in that spacing because 0 is one of them. And then you start at 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That's 10 numbers. You want every spacing to be equal. So we can go like by tens. That's something people messed up last year. They'd go from like 10 to 20 and then 21 to 31 and then 32 to 43 or something. Like, what? Make it as easy as possible for yourself. And then you tally the data. How many are in each one? So what you did, okay, so we made equal spacing. I looked at all the ones between 10 and 19. Like, oh, here's one, so I make a tally. Here's one, so I make a tally. Here's one, so I make a tally. And then I think the last one was like right here. Cool, so that's 5. And then the frequency is how many times it occurs. And the relative frequency is how many times does it occur over the total number of occurrences. So we have 42 Super Bowls that we charted here. And the number of times the winning scores between 10 and 19 was only 5. So it's 5 over 42, or 12% of the time. The score is that. Okay, so, and when you add all these together, it should equal 1, because these are percentages, and you want the total number of percentages to equal 1, because it has to encompass everything. So, let's see, these are always vertical. What else do I want to say? The class boundaries are the numbers used to separate classes, but without the gaps created by class limits. The class midpoints, the values in the middle of the class can be found by adding the lower and the upper and dividing by 2. So let's go through. So up for this for this chart that we're going on right now, what is our class width? How big? How many? 10. It's 10 numbers wide. You have 10 numbers per line. Let's see, what are the lower classes? What are the lower boundaries? 10, 20, 30, 40, and 50. We're just looking at the numbers up here. These are the lower. Guess what the others are? The upper class boundaries. 19, 29, 39, 49, and 59. So the class boundaries separate the classes. So, okay, at what point do I change from going from the first row to the second? At what point do I switch between them? When do I switch between the 10 to 19 and the 20 to 29? At what point do I flip from going from one to the other?
20.
At 19.5, because it rounds up, 19.5. Like, that's the split. Because it's not always going to be Super Bowl scores. It might be like, very real example, your power. Literally, you pay per kilowatt, but only for the first 1,000 kilowatts. And then after that, it's a different rate. So at what point do I switch from the lower rate to the higher rate? Oh, as soon as I reach the 19.5, I am now in the higher bracket. Because it rounds up. So the, let's see, 19.5, 29.5, well, technically 9.5, but we don't have a class for that one. 29, 39.5, 49.5. And then the midpoints are just halfway between the lower and the upper. So halfway between 10 and 19. Yep. 24.5, 34.5, 44.5, 54.5. Cool. All right, histograms are graphs with bars. It's like a bar graph. They're equal width, drawn adjacent to each other, just packed together. The horizontal scale represents the classes of quantitative data values, and the vertical represents the frequencies. The height represents the frequencies. Okay, that's what I was showing you with this graph. Hold on. Since I already had the data in there, that's why I was like, let me just show you it. Okay, here's my histogram. This is group 2, right? So if I change between group 1 and group 2, it's very clear. Like you can see the data is much more spread out versus group 2, they are really like more condensed in. You can like see how it condenses in. So notice on the left side, it's frequency. I could change this to be relative frequency. Oops, hold on. Nope, X out, come on. Oh. Come on. Histogram properties, I want relative frequency. Relative frequency percent. So, percent, aka relative frequency, 24% of the time. Cool. And you can change it back if you want. So, histograms are a graphic version of the frequency distribution, how many times each one occurs. What else? The frequency is the number of data values in the class versus the relative is like what percentage it is. So you can see the winning scores versus the percents winning. Relative frequency is just a percent. Quartiles. In a set of data, quartiles are the value that divide the data into 4 equal parts. So the median is literally halfway. It splits your data into 2. But what about if you're looking at the first half of your data? It's like the median of the lower half, aka this is the Q1, the lower quartile. So this is the bottom 25%, the like second 25%. It's like lower than average but higher than the first quarter. Then you have the median, and then you have the, I don't know, third. That was a better way of saying middle 25%. The 25% that's between the median and the third quartile. So more or less, these are your 5 numbers. You'll have a min, your Q1, your median, your Q3, and your max. These are called the 5-number summary. The Q1 is the first quartile. It separates the bottom 25% sorted values to the top 75%. Q2 is the second quartile. Well, that's just your median. It separates the bottom 50 to your top 50%. Q3 is your third quartile. It separates the bottom 75% to the top 25. So if you ever look at your PSAT, it tells you what quartile you were in for taking the test. So for instance, if you were the 63 percentile, that means you were higher than 63% of the test takers that took it. So it gives you a scale of where you rank with the 700,000 people that took the test the same day as you. Okay. Cool. Yes. Use the data set for the Super Bowl scores shown above to determine Q1, Q2, Q3. Okay. So we have to sort the data in increasing order. Ugh. Or you could enter them all into your calculator, and guess what? It will tell you for you. So let me go back here. Notice these. Let's go down. So it tells you your 5-number summary. It tells you your min, your quarter, Q1, first quartile, your median, your third quartile, and your max. These are the 5-number summary. Literally what I'm showing you right now, your calculator does as well. We already did it. Okay, so I want you to do the Super Bowl scores and then create your 5-number summary. I'm going to plug in my computer. Try it out. I'll give you like 30 seconds or so. So if you had to do this by hand, would you know how to do it? You just sort them and you literally find the median, and then you take your first half and find the median of the first half. So that would be for like an SAT question, but otherwise, cool. Knowing how to use your calculator is not a bad thing. But if I say like show work, I would want you to do it yourself. Okay. I'll hand out the homework and you can hopefully take a good stab at it. 5 topics of ALEKS are due Friday. Once again, juniors, you don't have to do it next week when you're on the junior trip. Also, juniors, there's a new class I'm trying to make happen. We just got the approval last week, so if you want to sign up, that would be cool. It's a project-based class, and you learn how to... It's like a coding class, but it's not an AP coding class, apparently. These other people made the curriculum. There's no test. It's all project-based. You learn how to make your own website and code. So I'm trying to make that happen for next year. Huh? No, it's a science. It would be a science elective. You have to have 3 years of lab science. Well, that's like physics, chem, anatomy, biology, earth science. But then you can like take other classes as well. I'm pretty excited for it. I just need to get people signed up so it'll run. But no harms if you're not interested. Just tell your friends about it. Cool. Okay. All right. Do we have questions about this one? So I'll hand out the homework.